So we're using a much more intelligent and brilliant way of compressing these things with run-length encoding and clever bit masks, and we managed to get something like a 10x size win on shrinking down our set, which we immediately used to massively increase the number of tiles we could use. So there's no memory saving, but there's a bandwidth saving, so that's all nice. And we should have a sort of tunable at some point to, I guess, be able to have more bandwidth or less memory use. So it's pretty nice. So we have all of these bit masks here that essentially the bit mask says, is the pixel the same as the last pixel? If it's set, then there's not much in the data. There's just not, and sometimes there's nothing there at all. So, you know, it's all alpha transparent nothing. And there's quite a lot of white in documents. You see that a lot. So, yes, I like this. This is fun. Look at this nice picture. Isn't it pretty? Well, we'll move on in a minute. But anyway, AVX2, so accelerated comparison. So one of the nice things you may not realize about your CPU is that 8 pixels at a time, each of them 32 bits, can be compared and swapped and added and done all sorts of clever things to. And by the power of Quailon's whatever, we can even turn, having compared them, we can turn this into a signed bit for a floating point and pack them into individual bits, which is great. So we can see if all of those pixels match, which is awesome. And it gives us about a 4.5x win on actually compressing these, which is quite a chunk of our performance budget, I guess, which is kind of good. So there's even a thing that proves it here by measuring it. I have a benchmark. Look at that. To be fair, we wrote the benchmark well after we'd done the optimization, but don't let anyone tell you that. That would be foolish. There's a particularly funny gotcha in the threading as well. Yours truly wrote this amazing threading scheme for threading tiles compression, so it should be much faster on multi-threaded machines. And it turns out that each of the threads did 1 tile and then nothing, which is kind of embarrassing because some idiot had put an if, not a while in the end. But anyway, there we go. We fixed that. So we got another sort of 4x for larger screens, which is kind of good. So we can convolve those. And we saw this by noticing in the flame graph that actually there was remarkably little happening in the threads, and it was all happening in the main process. So anyway, we moved it all to the threads. So you convolve those and you get about an 18x speed up for tile compression, which we're quite pleased about. And I think there's more to come there. So that's all good. There's a whole load of more other stuff that we moved over, some of it to the client side. So RGBA, shuffling, and pre-multiplication. The web standards, unfortunately, for no really good reason, use RGBA instead of pre-multiplied alpha, which no one in their right mind would use. So there's no real obvious reason why. It's not like it's even preserved in the canvas. You know, you write it in and you get something else out. I mean, there's just no benefit at all. But there you are, the web APIs. Go web. Anyway, so we moved the whole of that to the client, so we didn't have to do the maths on the server, which is good. This is a particularly funny one. This is where we, we're doing a lot of stuff here, drawing things, and probably it takes time to draw things, right? Like you'd expect that, right? Drawing slow, except here it's mostly looking through the 10,000 item cache as a list to measure the length of the list to see if it's too long already and we should remove 1 item from the end. And that's not great. So anyway, good to have speed up caches all around the place. A giant virtual device. Oh, yeah, so we used to have this where we would have this massive thing to avoid flickering, for some PC thing, and then this giant, a huge document area virtual device rendering to in the background, never using, throwing away. So we didn't do that. And that was good. And lots of space. This was particularly nice. So there's a benchmark built into LibreOffice that's run every time you upgrade. And for some reason, we just triggered this for every document that we launched. This was fixed early in the year. But it's nothing like dirtying 64 meg of RAM and then doing this benchmark into it every document you load. So 1 line and we got our initial dirty page count down to 20 megabytes instead of 84, which is great. So what else? Yes, tips. So people like to scan in huge documents, and that's great. And of course, we believe in keeping the compressed document around in memory so that you can uncompress it when you need it quickly, except if it wasn't compressed in the first take, you just got this huge thing and you then turn into another huge... Anyway, so we fixed a whole load of that. We even asked the glibc allocator to actually go and trim, can you do better? Compact your memory, free stuff up when you're idle. File save, this is a particularly fun one. There's a whole load of this kind of use case here. And the background save talk will help with some of these. But yes, allocating loads and loads of columns you don't need when you save for no particularly good reason. And yes, and we did some work to try and discourage calc users from heading off into the deep wilds with Core's wonderful control right arrow thing, ending up at the million rows and typing hello world in. It's not going to help your file format size or your, performance generally. So let's try and discourage that. And we have a better tool now that I think Neil is building on to do performance regression testing. So that's kind of cool. And there's lots more to be done. So keep profiling. Thank you.